All right, today we are working on a good old Whirlpool built, Kenmore labeled, but same machine built by Whirlpool dryer. This is an electric dryer. And the complaint on this one is that the motor runs, but no heat. So everything sounds fine, and the motor obviously is running. We're just not getting any heat. So what we're gonna do, like we do always, is we're gonna look at the schematic, and that's gonna be our strategy guide in how we're gonna troubleshoot this. It just takes a second once you get used to it. Looking at these, it just takes you a second. So we've got, here's our heating element for the electric. We've got L1, L2, so 240 volt load. The L1 side goes through a heater relay that's on the board, and then you've got a thermal cutoff and a high limit. Both those are on the heater itself, and then the motor centrifugal switch. So there's a separate switch that's mechanically actuated by the motor when it's spinning. That controls L2. L1 is controlled by 1, 2, 3 switches, if I did that higher counting correctly. So the idea here is first we're going to go back and we're going to verify that we have a good 120, 240 power supply to this circuit. Ain't nothing else going to happen if I don't have a good power supply. Then I'm going to verify, because I'll be right in that neighborhood, I do minimal disassembly for troubleshooting and then save teardowns for repair when possible. That's the general rule. There's always exceptions to that. So here's a heater relay. It's on the control board right back behind this panel. And I'm just going to verify that I'm getting L1 out that heater relay when that relay closes to call for heat. And then if I'm getting L1 there, then I'm probably looking at an open in one of these switches. Or the heater load itself, maybe even the centrifugal switch in the motor. At this point, we won't know until we start doing some more measuring. So let's go do that. All right, so first thing we're gonna do is verify that we have a good power supply back here at the pigtail. And simple access there. We're gonna use our handy meter, and we're gonna use it on low Z. Got to have a meter with low Z on it. A lot of open neutrals, bane of our existence, open lines, all kinds of stuff go on. And if you're using the VAC function, you're going to get head faked. Use the low Z, and it'll keep you from getting head faked by ghost voltage. So let's just first measure L1 to L2. And there's our 240. And line to neutral. I'm not sure which line is which, but we got 120. The other line to neutral, and we got 120. So we have a good 240, 120 power supply. That's not the issue. We're going to continue now going inside the dryer. We're going to go look at the output of that relay that we were talking about and continue on in a logical stepwise fashion. All right, so again, here's our circuit. We checked our power supply. So we're going to look at the output of this heater relay. That means the dryer is going to be plugged in and running and calling for heat. And when I'm going to look for voltage between the output of this relay at COM1, between there and the neutral lug on the terminal block. It takes 2 leads to make a voltage measurement. So even though we say we're looking for voltage at a point, what we really mean is we're looking for voltage between this point and our reference point. And our reference in this case is going to be the neutral lug on the terminal block. So we're going to look for voltage there. Should be at 120 because I should have L1 to neutral when I'm doing that measurement. So let's do that now. All right, so for this one, we're just going to undo a single screw back here and get access to the control board. Slips out like so. Free up your wire harness. So there is our heater relay. That's the black wire coming in, and this violet wire is the output. Let's jump back up here to just like what they're showing you. See, this isn't rocket science. Black is your incoming L1, and then the output from this relay, that's the K1, K2 heater relay, is this violet wire, V. That's the output, and it goes on down to the thermal cutoff. So that's what we're going to be measuring is for voltage from this violet wire here down to the neutral lug, which is the middle one, on the terminal block. And I should have 120 volts if that relay is good. Be able to hear the click. It's already closed, but come up here and look. So we've got our 120 between the violet wire where my red probe is, and look down here. My black wire is right there in the neutral lug. I can put it anywhere in there. Between those 2 points, I've got 120. That means that this relay is closing. I wouldn't have 120 there if that relay weren't closing. So the problem is further downstream or in the motor centrifugal switch. Now we go in. In this case, we've got no choice but to go in and look at these switches and test them and find out which one is the bad actor. All right, so why didn't I measure across the relay? You know, if all these switches are good and the relay's open, let me just draw that in for the purpose of discussion. Suppose that relay is open, then what I should measure with my meter from black to violet, I should measure what? Again, assuming all my switches are good and I've got a good L1, good L2, I should measure 240 VAC with the relay open. And then when the relay closes, that 240 VAC should go to 0 VAC when this relay closes. So we're going to measure and see what's actually going on in this one. A little surprising twist and with a little nuance to the low Z story. And for this test, we're going to be using my fluke set. Same functionality, just does it in 2 different meters, which I actually prefer. I like having a separate amp meter because sometimes you want to monitor volts and amps at the same time. Sometimes you want to get your meter set up for volts and then you don't want to have to screw around with the leads again while you're looking at amps on the circuit. See if you got any or not, or if they're in spec. So the other thing I like about the fluke is this strap with magnetic on it back here. Really cool. That's a strong magnet. So I can get this set up and it's not sliding all over the place. So what we're going to do is we are going to, for this test, all right, so here the control board comes out with a single screw, right? Not a big deal. Fish the control board out. There's the heater relay, the black and violet wires, and there, now we can see what we're doing. So let's put, our meter is set on low Z. We're going to put our probes in place and turn the dryer on. So 0.4 volts on low Z, basically that's 0. So we're on a cycle calling for heat. We're going to go ahead and start it and see what happens. Oh, error code. F4E1. Let's look at that. All right, so here's our F4E1 heater failure or connector problem. But here's the big clue. Indicates no voltage detected at the heater relay. What does that really mean? Well, if you keep reading, F4E4 is an L2 line voltage error, indicates low voltage at the ACU. Both of these, the heater relay is on the ACU. So they're explicitly telling me in the error code that there is voltage sensing going on within this relay, and somehow my meter on low Z is messing with the voltage sensing. They don't tell us anything. They're not showing how that voltage sensing works here in the schematic. The only way I know about it is by reading their short little description on the associated error code, the F4E1. So now, let's try something where we are going to do that same measurement, but we're going to do it instead of on low Z, we're going to do it on VAC. Since we know there's voltage sensing going on in this circuit, and we know that low Z is messing with it, because what's happening is on low Z, your meter is actually acting as a load in the circuit. Remember when we first had our probes in there, that it was reading 0 volts? Well, let's see what we got going on when we do that down here on VAC. Let's do the same measurement. Oh, 103 volts. But we know, let's switch it back to low Z. 0 volts. So this board apparently is sensing voltage at the heater relay, but but it's just ghost voltage. And in fact, the between the two, because line 2 is open, line 1 goes directly to the black terminal on the relay, but it's sensing voltage something like what your voltage sniffer does. These will go off. You got to look at the range on it, but it must be doing something similar to that. Anyway, fun fact to explore that. So let's now repeat our test with this on VAC instead of low Z. Got our ghost voltage back. Okay, we are back up, and let's run it. And listen for the relay click. There, it clicked. I could feel it click through the probes, and now it goes down to 0. So somehow the voltage sensing is looking for that change from whatever junk voltage, ghost voltage is on the line to 0, which you would expect to be 0 when this relay is closed, because a voltage across a piece of wire, voltage drop across a piece of wire should be 0. And that's what a closed switch acts like a wire. There, I'm back on it now. My probes are wiggling a little bit. All right, so now that we've established, and we felt the relay click. I felt it click, which is an indication that the relay is closing. It's not conclusive proof, but it is a good indication, and that our problem probably lies elsewhere. And just to confirm, we're looking at amps here. We got no amps. Electrons are not moving in this circuit. So, which means that, okay, maybe there's a slim possibility the relay is still open, but more than likely, we have an open, so we're going to go down in there. So, again, just an example of using the schematic to understand electrically what's going on with the components that you're seeing. All right, so obviously, I forgot to mention it before, we removed a panel. This is it here. It's just a bunch of screws and stuff. I think it's 6 of them that hold that on. No big deal. 6 1/4-inch hex screws. And then down here is where we're going to be working next, because the heating element is back behind this panel. So I've got most of these out. I've just got to remove a couple screws on each side, and then we'll remove the panel. Then we'll get into testing the controls. Okay, so we've got the back off, and here's our heater can right here. Here are 2 controls right here. We've got, if you look over here, we've got a thermal cutoff and a high limit. And how do you know which is which? Which is the thermal cutoff and which is the high limit? Well, again, the schematic will tell you. That's one way to do it. I'm going to show you another way to tell as well. Let me turn my light off here. Look here, this V, violet, R, red. In other words, the thermal cutoff has a violet and a red wire connected to it. What do we see here? A violet and a red wire. And then, meanwhile, your high limit has 2 red wires. You can see down here, you have red, and then actually you don't even need a wire on the other side of it because it's hard connected over here to this side of the heating element. Just as they show here, they don't actually show a red wire. It's because it's just a metal bond over to this tab through the high limit. And then L2 comes in on this side. So, and that's just going back and forth between what you see on the dryer and what you see in the schematic, and using the schematic to tell the order. The other way to tell the difference between the thermal cutoff and the high limit, if you go over to, this is the last page in the tech sheet, and they tell you explicitly, thermal cutoff, turn off this light, and high limit on the electric versions. There's your heater can in back, and there's this control's only using the gas model. We've got the electric model here, thermal cutoff up here, and then your high limit. So that's the other way to tell. But if you can read the schematic, easy way to tell is just look at the schematic and it tells you. So what we want to do is go through and test these controls one at a time. And since this is the next one in line, so to speak, with the L1 supply to the heating element, we'll start here. And what I'm going to do is I'm actually going to, and we're unplugged. See back here, we're unplugged. So by the way, when you do any disassembly back here and you're putting your hands in, go ahead and unplug. And then save the live testing for when everything's secure and you're actually ready to test. Just test this with ohms. because I know that's everyone's favorite test, and we don't want to disappoint. We are crowd pleasers here. So we've got our meter set on continuity. Beep, beep. All right, so, oh, look at that. It's open. So at this point, you could just replace it. What I like to do though is put in a jumper wire. All I did was pull the power wires off of this switch. I'm jumping it out now, and then I'm gonna check amps. And if I'm drawing 20 plus amps on this circuit through my heater, that's about right for a heating element and a dryer. I'm looking for something in the 20 plus amps range. That means it's getting hot. I don't even have to wait around for it to get hot, although it does it quickly. So what we're gonna do is we're gonna put our meter on amps. We're gonna plug this in, fire in the hole. We are plugged in. We're gonna turn it on. We're gonna run it. We're gonna look at amps. 23 amps on that heater circuit going through my jumper wire. Now when you do this, make sure your jumper wire is big enough to handle the amps going through here. This one's doing fine, it's not even getting warm. But you don't want to use a little bitty jumper wire if you're going to be running 22, 23 amps through it. So this is all good. In fact, now you can smell the heat. All these amps are doing something. They're making watts somewhere, and those watts are doing work somewhere. So what I've done, what have I accomplished by jumping this out? One, I've proven everything else in this circuit is good. I don't have to worry about the motor centrifugal switch. I know the heater's good or would not be pulling amps, and I know the high limit is good. I can stop right here. I'm gonna unplug, and from this point then, it's just a matter of removing my jumper wire and replacing the thermal cutoff, which is the defective component here. And that is this guy. All right, so what I did is I ordered the maintenance kit for this one, which has just all the controls. One of these, they're all the same age. So your thermal cutoff, your high limit, and your thermal fuse over here, which controls the motor. When that opens, it kills the motor circuit. They're all the same age. If one goes, go ahead and change them all. And that's what I'm gonna be doing here. So I've got the thermal fuse, that'll be replaced there. And I've got the high limit, you replace there. And I've got the thermal cutoff, which is, actually part of this kit. Okay, so just a little bit on the jumper. Here's the jumper wire that I used. Notice that I terminated it with 2 male spades. So because if you're jumping out a switch, what that means is you're going to be plugging into the harness that goes into that switch. Well, most of your harnesses are female terminals. So here's the switch, and it's got the male spades. So if I'm going to jump out the harness to the switch, then I've got to use a jumper that can accommodate the terminals. Female terminals in this case require male terminals. I just go in like that, and that's my jumper. Okay, so we've got all the controls in. We've got a new thermal cutoff, we've got a new high limit, and we've got a new thermal fuse. Went ahead and replaced all of them. So let's go ahead, just to make sure everything's good, while we've got it open in case there's a problem. Maybe I induced a problem with the repair. Very rare and unlikely, I know, but it can happen even to the best of us. So what I'm going to do is plug it back in, and we're going to check amps. And I can check amps anywhere on this circuit. I can just put my amp clamp any convenient pointer on this circuit. Since I'm also already back here, I'm just going to grab it around this purple line here. So I'm going to turn the dryer back on. And there we are. Did you hear the relay click? That was the heater relay on the board. And then we've got our 20 plus amps on the heater circuit, which means I didn't induce any errors, and the only problem was the thermal cutoff right there. So we got fire in the hole, so when you do this, just don't do anything stupid, don't touch things. You're just doing electrical measurements. It's all cool, and this tells you everything. Okay, so that was a real simple example, just showing you this whole tech thing that we do, using the schematic to troubleshoot your load of interest, in this case with a heating element, using the schematic to look at the circuit for your load of interest, look at the switches, testing the switches, proceeding in a logical way. So, and we also looked at using a jumper wire to jump out your suspected switch. In this case, we had a bad thermal cutoff. And so we used the jumper wire with male tabs on it to jump out the wires, the switch, by jumping these two wires together with our jumper wire, properly rated. And then finally, we also used an amp measurement at the end to verify that we were pulling the proper amps for our load, the heating element. And we were getting 20 plus amps. That's after we were all done, just to make sure everything's working right. And there we go.